Alrighty, hi guys, good morning, and welcome to the second part of today, which is using straight line graphs to solve quadratic equations. Now, I'm going to level with you. I don't love this little bit of a topic, mostly because we have so many other ways of solving quadratics other than using graphs. We have quadratic formula, we have factorizing, we have just kind of simple solving, and they're all very quick, very easy, and they're stuff that we're really used to. Now, being able to use a graph to solve an equation, I don't think for quadratics it has a huge amount of relevance, but we have to start off here because we're going to need those skills for when we're dealing with other graphs or other equations that we're maybe unfamiliar with, and we need to have a graphical technique to solve it. So this is going to seem kind of pointless and stupid today, I'm aware of that, but I hope that tomorrow when we move on to looking at cubics or exponentials or other graphs of other equations, then you'll kind of see the relevance of this technique coming in. Okay, so first thing we're going to do is we've got an equation, it's y equals x squared minus 2, and we're told that we're graphing it, we're looking at the domain of from -4 to 4 for x. So we're only graphing over a specific set of x values, specific domain for our function. And then we're told we want to draw a suitable graph and solve for where y equals 0. Now, normally when we're solving, and again, this is where it's going to kind of come in and be a bit stupid. Normally what we would do is we would take write down our function first, y equals x squared minus 2. If we want to solve for where y equals 0, we let y equal 0. We end up with x squared minus 2. Then we could take the 2 onto the other side, so we'd end up with x squared is equal to 2. And then we could take the square root of both sides, and we'd end up with x equals plus or minus the square root of 2. Okay, that's about, 1.6-ish, 1.614, I think, or something along those lines. Now, when we're solving this equation using a graph, though, we're going to do it slightly differently. So we're still going to let our equation equal 0, because that's where we're trying to solve for where y equals 0. So we're going to let y equals 0. Okay, so our equation then becomes x squared minus 2 equals to 0. We're still going to bring the 2 onto the other side, and we're going to end up with x squared is equal to 2. Now, from this case, you can hopefully see that what we have here is we have an easy to graph algebraic expression with x squared, and we have a constant value 2. Now, this isn't always going to be a constant. We could have an algebraic expression equal to another algebraic expression, and we could graph that. But in this case, we're looking at x squared, and where that's equal to the constant 2. Okay, so now what we can do is we're going to sketch the graph of x squared over our domain from x equals to x is bigger than -4 and less than 4. And we're going to sketch our constant value. So I'm just going to write down my values here. So if we start off at the bottom of the domain, we've got -4 squared. I'm using blue for the x squared, by the way. -4 squared is 16. So my first value I'm going to graph is 16, -4, 16, which is here. Okay, I'm going to put that in there. Okay, I've then got -3 squared, okay, which is 9. So I'm going to chuck that in here. Okay, -2 squared, which is 4. Right, -1 squared, which is 1. And 0 squared, which we know is 0. Okay, now it's a basic quadratic, so it's going to be symmetrical on both sides. So we're also going to have another point at 1, at 2, and at 4, at 3, and at 9, and at 4, and at 16. And if you wanted to, you could go through and actually, work all of those out. But we know, our x squared graph is a symmetrical graph, so you shouldn't have to by any means. All right, so now we can join those up. Okay, I'm going to try and do this as neatly as I can, because you do need to be quite accurate for this, but it is really hard on my drawing board. Well, that's actually, that's not terrible. Okay, perfect. So there's our graph of x squared. So the first thing we've done is sketched, actually I'll use correct terminology. We have actually plotted, because we've got all the points there. So we've plotted the graph x squared. Okay, now we're going to plot graph y equals 2. Okay, so just that horizontal line, I should say that's there, that's y equals x squared. Okay, we're going to use y equals 2, which is just going to be our horizontal line, which is going to go through 2. So at here, I'm going to use the same points again. So we're going to have negative 4, 2, negative 3, 2, negative 2, 2, negative 1, 2, 0, 2, 2, 2, 2, 2. Lovely. Okay, and now I'm just going to draw a horizontal line again. I'm going to try and do it neatly as possible. Okay, through there. Beautiful. So now I can see that my points of intersection, or my solutions, are at about, it's about negative 1.6 there, and here at about positive 1.6, okay, which is the same as what we would have, you know, if we took the square root of 2, you know, oh, sorry, 1.4, I'm not talking about 1.6, 1.414, okay, so there should be, and actually, I'll change that, because I actually think that's more like 1.5 on my graph, so it's about negative 1.5, negative 1 point, and positive 1.5, around about, okay? So, again, I don't love this because it's not very accurate, I don't think. And it's, yeah, I find it not very accurate, and I find it, you know, a little bit frustrating in terms of actually getting the solutions. The other thing is, we haven't kind of 100% finished, because then the last thing you should do is write down what your solutions are. So I'm just going to put a therefore sign. I'm going to say x squared minus 2 is equal to 0 at negative 1.5 and 2, okay, because obviously it's on that y equals 2 line, and positive 1.5, 2, okay, so there's my coordinates. So that's my finished kind of solved equation. All right, next one. This one's a little bit more complicated. So we've got a similar kind of idea. So we've got y equals x squared, but now we've got minus 4x plus 3. So whenever you've got a bigger quadratic, we're just going to do the same thing, but instead of making it equal to a number, we're going to make two algebraic expressions equal to each other. So we're solving again for where y equals 0. So the first thing I'm going to do is I'm going to let y equal 0, and therefore my equation is x squared minus 4x plus 3 is equal to 0. I'm going to bring over everything that's not an x squared onto the other side of the equation. So I'm going to have my x squared on one side, and then on the other side, I'm going to plus 4x and minus 3. Okay, and that cancels that out there. So I'm going to end up with 4x minus 3. All right. Now when I'm sketching my graph, I'm sketching a quadratic versus a linear equation. And again, I'm going to plot this. I'm just going to do this really quickly. So in this case, I'm going from negative 5 to 5. So I'm starting off at negative 5, 25. Then I'm going to go negative 4, 16, negative 3, 9, negative 2, 4, negative 1, 1, 0. Back in the other directions. If you guys want to go through and plot this, you know, kind of a bit more methodically, take your time over it. I'm rushing it because I've only got 15 minutes to make this video. You know, I'm up to 8 minutes already. Okay, so again, I'm just going to join these up as best I can. The more accurate you can get this, the better. Well, this positive side looks all right. There we go. Okay, perfect. So there's my quadratic. Now I'm going to take my linear part, and this side you do kind of want to work out the values because they're not always going to be the same. Hopefully you're noticing that if you're using just an x squared, you don't need to work out the values every time because they're always going to be the same. You're just squaring whatever your x value is. And that's kind of one of the nice things, I guess, about it. Okay, so first thing is we're starting off at negative 5. So I've got 4 times negative 5 minus 3. Okay, so that's negative 20 minus 3, negative 23. So I'm starting off at negative 5, negative 23 down here. Okay, then I've got 4 lots of negative 4 minus 3. Okay, so that's negative 16 minus 3, so negative 19. 4 lots of negative 3 minus 3, so that's negative 12 minus 3, negative 16. And hopefully what you can see here is these are all going up by 4 every time. In fact, that should be 15, not 16. Sorry. Negative 12 minus 3, negative 15. So these are going up by 4 every time. So once you've done a few points, again, you don't have to do all of them. So each of these, they're going up by 4. So I can go across 1, up 4, across 1, up 1, 2, 3, 4, across 1, up 1, 2, 3, 4, and that's because, you know, the gradient of that straight line is 4. So that's the reason behind that. So across 1, 1, 2, 3, 4. Across 1, up 4, 1, 2, 3, 4. Across 1, 1, 2, 3, 4. Across 1, up 1, 2, 4. Now I'm just going to check that last point just to make sure that I haven't mucked up any of these values. I'm just going to check. So 5 times 4 minus 3, so that's 20. Oh, and I've done that the wrong way around. That should be 4 times 5, not 5 times 4. 4 times 5 minus 3, so 20 minus 3 is 17. Okay, so I should be up at 17 here, which I think 15, 16, 17. Oh, I'm 1 off. All right, just give me a second. I'll just fix up where I've gone wrong. I've just gone up 1 too many between 0 and 1. So that should actually be on the line, which actually makes the solutions for this a lot nicer. So if we now draw up these lines, okay, I'm going through this point there. I'm going to try and get at least the points of intersection right. Okay, beautiful. So there's my graph. Okay, so now I can see, again, my points of intersection in this case are at, now that's exactly crosses that line at that point there. So that there is my coordinate 1, 1. Okay, so that perfectly crosses the line. And the other one is this one here, 3. Okay, and that's 3, 9. So that's my other solution, okay, where they've crossed over. So I can put in here, I'm going to have, so 4, 0 equals x squared minus 4x minus 3. X is equal to 1, or x is equal to 3. Now remembering here, we're solving for where y equals 0. So we're actually, you know, up above I wrote the coordinates in with 2 and 2, but we're actually really only interested in the x values because we're trying to find where it's equal to 0. And I'll show you on GeoGebra. Here is our graph. Okay, and we can see here, so that's x squared minus 4x plus 3, and you can see there you've got an x-intercept at 1 and you've got an x-intercept at 3. So that's our coordinates there. So that's our solution. Alrighty, next one I want to do is just a little bit more complicated, and then we'll call it for today. So this one here, we've got for y, we've got again same process. So we're solving for where, in this case, where y equals to 3, negative 3. So we're going to let y equal negative 3. Okay, so we got negative 2x squared minus x plus 10 equals to negative 3. Now, same as before, we're going to take the other stuff, the non-x squared terms, onto the other side. So we're going to add x and minus 10, cancel those out. So we end up with, I'm just going to keep that red for the moment, negative 2x squared is equal to, oh, guys, I'm really sorry. There might be a second video for this one. I'm running out of time. X minus 13. Okay. And then I'm going to divide that through by negative 2. Because again, I only want to have the x squared. I want to keep that nice and constant. So I'm going to keep my x squared on this side. And then I'm going to graph here. Now this is going to be negative 1/2 x. And that's from that negative 2. Okay. Because you imagine that's like that's x divided by negative 2, which is the same as negative 1/2 x. And then a negative divided by negative is a positive, so then I'm going to have plus 13 over 2 here. Okay, so there's my linear equation, because I've got an x and a constant, and there's my quadratic. And I'm graphing again from negative 5 to 5. So I'm just going to chuck that in there. In fact, what I might do is I might actually, because I don't want to make this 2 videos, so I might just pause this, I'll draw it, and hopefully we'll be able to save some time. Okay, so there we go. There's the graph, the green linear equation, blue quadratic. I'll just show you. I actually used the table on the calculator to get the linear values, and feel free to use that if you want to. And for this one, because we're not solving for 0, okay, our coordinates are negative 2.8, that's that one there, and negative 3, and 2.2 and negative 3. Okay, so hopefully you can work that out a little bit better by yourselves. And that's it for today. I'll send you some questions. Okay, bye.